Hello students, welcome to the part 9 of the chapter Electrochemistry. In this chapter, in this part, we are going to see different factors that is affecting the product of electrolysis. So in the last part we have seen different laws that is governing electrolysis, Faraday's first law and Faraday's second law, that were connecting the variables like quantity of electricity and the amount of substance deposited on the electrode. In this part we are going to see different factors that affects the products of electrolysis. So mainly they are of two factors. First one is the nature of electrolyte, and we will see details about this, and also the electrode type. So far we have learned that there are two types of electrolytes: inert electrodes, they are inert electrodes, and reactive electrodes. So these are the two factors that influences the products of electrolysis. One is the nature of electrolyte and the other one is the type of electrolyte. So throughout this part we will see the topic here on the top, and one by one we will deal. First we will look into the nature of electrolyte. So nature of electrolyte. Electrolyte nature is going to influence in different ways. The first is electrolysis of fused or molten electrolyte. So fused or molten means electrolyte is something that dissociate into ions in a solution, in a solvent. I would say electrolyte is something that will dissociate into ions in a solvent. But even without adding into a solvent, you can ionize them by melting the solid. So electrolyte, they are ionic compounds. They contains positive cation and negative anion. This electrolyte, if you are adding into water, will dissociate into ions. At the same time, if you are melting the electrolyte, they will dissociate into positive and negative ions. In such melt or in their fused state, there will be only ions of electrolyte. There won't be molecules of water or any other solvent. So if electrolyte is melted, they have only ions of electrolyte. Let's see an example in the case of magnesium chloride. If you are taking magnesium chloride salt and you are trying to melt it, then after melting, that substance or the liquid form or the melt form will have two types of ions, that is Mg2 plus as cations and Cl minus as anions. What happens if I am conducting electrolysis using this melt, that is of positive and negative ions? Let's see with a diagram. So I have an electrolytic chamber that is connected to two electrodes, anode and cathode, positive and negative. Now it is dipped into molten form of magnesium chloride. So automatically positively charged magnesium 2 plus will move or gets attracted towards negatively charged electrode, accepts electron, and reduction takes place. Since it is reduction, the electrode is cathode. On the other hand, chloride ions, which is of negatively charged, move towards positively charged electrodes, give away electrons. So it is oxidation, and hence it is named anode. So let's look into the reaction of anode. In the anode, negatively charged chloride gives away electron. One electron by one chloride, two electrons by two chloride, and the resulting chlorine atoms combines to give chlorine molecule. So that means at anode chloride gas will be evolved, because chlorine is in the form of gas. So it will be evolved in this anode, and it will be collected by fixing a chamber here. A container, gas container will be fixed in the real electrolytic chamber, so that the chlorine gas coming out of this solution can be collected over anode. What happens to the cathode? Magnesium slowly goes to the cathode. It accepts 2 electrons and get deposited on the cathode as magnesium metal. So the result is magnesium metal is deposited at cathode and chlorine gas is liberated at the anode. So what is the factor that is affecting the products of electrolyte here? It is nothing but, in the melt there is positively charged cation and negatively charged anion. So this positive charge is drawing it towards the cathode, and negative charge of chloride is drawing it towards the anode. So oxidation and reduction. We will see one more example of this type, that is in the NCERT textbook, that is electrolysis of molten NaCl. Again here NaCl in its molten form will give Na plus and Cl minus ions. So if you dip, like we saw in magnesium chloride, in the case of magnesium chloride, towards positive charge chloride ions will move, and towards negatively charged electrode Na plus ions will move. Here reduction takes place, hence it is cathode, and in the case of positive electrode, here the oxidation takes place, hence it is anode. What is the anode reaction here? Like before, Cl minus will give away electron and form Cl atom. 2 such Cl minus will give 2 Cl atoms, which will combine to form Cl gas. In the case of cathode, Na plus will accept 1 electron, that is reduction, and get deposited on the cathode as sodium metal. So what are the products? On the cathode, with the molten NaCl, Na is deposited, whereas on the anode, Cl minus gas is liberated. Here too you can collect chlorine gas from the cathode. In the last case it was magnesium, here it is sodium. You can collect the metals from cathode and magnesium. So this is the molten form. How it is influencing, how the nature of electrolyte is influencing the product. This is what we want to see. So I have taken molten form of NaCl, and what I got is sodium at cathode and chlorine gas at anode. What happens if I am dissolving, instead of melting sodium chloride, I am dissolving our salt NaCl in water? I am dissolving NaCl in water. Then it is called aqueous NaCl, or simply brine. Brine means it is salt solution of NaCl. So if I am using NaCl instead of this in the electrolytic chamber, instead of sodium at the cathode, hydrogen gas is liberated at the cathode. Why? So again, in this particular experiment or electrolysis, I was using melt of sodium chloride, and at the cathode what I got was sodium. Whereas if I am using aqueous NaCl, I will not get sodium metal at the cathode. Instead, hydrogen gas is liberated at the cathode. The question is why? So this can be used as an example to explain nature of electrolyte will affect the products of electrolysis. We will see why, but before that I just want to mention that here we used melt, here we used aqueous solution. So by using that, products have changed. Here I got Na, sodium, whereas if I am using aqueous solution of NaCl, I got hydrogen gas at cathode. We will come into the details about why we are getting that. So the outcome is that nature of the electrolyte decides the products of electrolysis. Okay, now we will see why we get hydrogen instead of sodium if we are using aqueous NaCl. That is electrolysis of aqueous NaCl or brine. This is an important topic, frequently asked in many board questions. So electrolysis of aqueous NaCl or brine. If you look into the aqueous NaCl solution, we will see that apart from the melt, in melt there was Na plus ions, Cl minus ions. Apart from that, we also have H2O. So H2O can also be considered as an electrolyte. Why? It has, even if it is a covalent bond, it is weakly ionizable, and also in H2O it has one positive part, that is H plus, and the other one is negative part, or you can say hydrogen is in plus oxidation state and oxygen is in negative or minus oxidation state. So we have that difference. This difference makes this molecule, which is a solvent here, a potential electrolyte. So we have different electrolytes here, multiple electrolytes. In melt there was only Na plus and Cl1, Cl minus, there is only one electrolyte, whereas if you are taking aqueous solution, we have multiple electrolytes. So we can say that this electrolysis is an example for solution with multiple electrolyte. If you are using electrolyte alone, and if you are using multiple electrolyte as a solution, then the products of electrolysis vary. That's what we meant by nature of electrolyte. Let us see why we get hydrogen while I am using aqueous NaCl for electrolysis. So we have Na plus, Cl minus and H2O inside the solution. Among this, first we will see Na plus. What is its tendency? Its tendency is to get reduced at cathode. So it will move towards the cathode and get reduced by accepting electron. It will, Na plus will reduce into sodium metal. So Na plus has a tendency to reduce at the cathode. It will move towards the cathode and get reduced to or get deposited as sodium metal. So this is the tendency of Na plus. What about Cl minus? It has a tendency to move towards anode and get oxidized there as Cl2 gas. Cl minus will get oxidized as Cl2 gas. This has also a tendency. So all the cations and all the anions have similar cations have a tendency to reduce, whereas anions have a tendency to oxidize. What about the other one, the third one, water? Water is a peculiar molecule. Since it is having positive and negative polar ends for this molecule, there is positive polar end and negative polar end. It can oxidize and reduce. It tend to reduce and tend to oxidize due to its polarity, and also it's giving out ions. Though the ionization is very weak, it is giving out ions H plus and OH minus. So as a whole, you can say that there is a polarity on the water molecule, where hydrogen is having a positive polarity and oxygen is having a negative polarity. Let's see what happens if water is getting reduced. This is a reaction. We have to study this. Reduction. Reduction means in water molecule, if you see, you will see that there are two types of atoms. One is hydrogen. It is having positive charge, and oxygen is having minus charge. Which among them will reduce, hydrogen or oxygen? Oxygen, for example, is in its lowest oxidation state. It cannot reduce further. Whereas hydrogen, which is in +1 oxidation state, can reduce. So H plus inside water will reduce to give hydrogen. So H plus ion will reduce into hydrogen. This is the reduction reaction that is happening if water is acting as an electrolyte. So water tend to reduce, so it moves slowly to the cathode, and at the cathode what happens? Water accepts one electron, and which atom among the water will accept the electron? Hydrogen will accept the electron, and it will get converted to one hydrogen will accept, and it will get converted into hydrogen atom, or you can say half H2. You won't represent hydrogen as atom. Instead of that, you can represent as half H2. Or if you want to eliminate half H2, just multiply the entire reaction with 2. Anything will do. Okay, so H2O plus accepting one electron, because it is reduction of water, accepts electron, and from this water molecule one H will accept the electron. It is an H plus oxygen state, accept the electron, and it will turn out into an H atom, or half H2. What is remaining here in water? It is OH minus. So OH minus will be there in the equation as product. That means, if you consider it in another way, water molecule can ionize into H plus and OH minus. Among these, H plus will accept electron to form H2 atom, and as a result OH minus will be there as product. So you can consider this reaction in two ways. According to your convenience, you can memorize it. So I always do it like this: H2O, in this H is the one that can be reduced, so it will take away electron and get reduced to atom, hydrogen atom, or half H2, and the rest of the part will be there as the product, that is OH minus. This is the reduction reaction of H2O. So which all species now have the tendency to reduce? First is Na plus, has a tendency to reduce, and the second is H2O, has a tendency to reduce and get liberated as hydrogen gas. In the solution there will be OH minus living behind. Again, what is oxidation of water? As I said, water tend to oxidize and reduce. So how does water oxidize? Again, looking into the two types of atoms, hydrogen is +1 oxidation state, that is its maximum oxidation state. It can't go beyond that. So that means hydrogen will not oxidize, whereas oxygen is in -2 oxidation state. That means it can get oxidized to its elemental form. So in water, oxygen will get oxidized to its elemental form. So in water, oxygen will get oxidized to its elemental form, that is oxygen atom, or half O2. Let's see the reaction. H2O, if it is getting oxidized to its elemental form, we will get, there is only one atom, we will get one atom. So from -2 to 0, again from -2 oxidation state to 0, from -2 to oxidation state to 0, oxygen from -2 to 0 means that -2 to 0 means that it will leave 2 electrons out. By doing that, both hydrogen from this molecule will be going out as H plus ions in the water. So again, oxidation of water, I always remember it like this: whenever there is an oxidation of water, it is going to be oxygen that is oxidized, which is in -2 oxidation state, will go to 0, that is its elemental form. -2 to 0. If it is going from -2 to 0, that it will leave 2 electrons, or it will give away 2 electrons. And while doing that, both hydrogen will go into the solution as H plus ions. So at anode, there is a tendency for water to liberate oxygen gas. So to conclude this slide, if you look, you can see that there are two species that have a tendency to reduce. One is Na plus, it has a tendency to reduce. Similarly, water has a tendency to reduce to liberate hydrogen gas. On the other hand, there are two species in this solution that have a tendency to oxidize. Cl minus has a tendency to oxidize to Cl2 and liberate Cl2 gas, whereas water has a tendency to oxidize to liberate oxygen gas. Let's see this in an electrolytic tank. So if you are conducting electrolytic tank, conducting the experiment or electrolysis of brine. Brine means sodium chloride solution. You will see that inside the solution there are Na plus ions, Cl minus ions, as well as H2O water molecule. So these Na plus and certain H2O molecules will move towards cathode for what? For reduction. Na on reducing we will get sodium metal, and water on reducing you will get. Reducing means it will accept electron. Which will accept electron? Which one is in its oxidized form, that is H is in its oxidized form because it has H plus, so it will accept electron and become H2. So we will see that reaction. So reductions, there are two species competing for the reduction. Here at the cathode, two species are competing. One is sodium, the other one is water molecule. This reaction we have already seen. Reduction means it will give out hydrogen gas, leaving OH minus in the solution. Which among these two this will succeed? So only one species can undergo reduction at the cathode. Though both will compete for reduction, only one species, just one species, either sodium, Na plus or water, can succeed in reduction. Which one will succeed? Before that, what happens in the anode? Again, there are two species, Cl minus and H2O, will compete for oxidation there. So what are the oxidation reactions? Cl minus to liberating Cl2 gas, and again water molecule liberating oxygen gas, leaving 4 H plus ions in the solution. So at the cathode there is a competition between sodium and water, and at anode there is a competition between Cl minus and H2O water. Who will succeed? To know that, we should know the E0 values of these all these half reactions from electrochemical series. I hope you remember this. When we were explaining electrochemical series, we found a table where all the redox half reactions is having an E0 value, that is a reduction potential or electrode potential. What is reduction potential? It is a measure to see whether a species can reduce, how strongly a species can reduce. So if you're looking into the electrochemical series, you will see this reaction and its value and their values here. So Na plus has a tendency to reduce, and its E0 value is 2.71 volt. Similarly, water has a tendency, this is our She, that is standard hydrogen electrode. H plus is getting reduced to H2. Whereas if you look into the electrochemical series, you will see the reactions in the opposite order. Cl2 accepting electron to form Cl minus, and you will see the oxidation, its E0 value is 1.36 volt. Similarly, oxygen is getting reduced to H2O. This is what you will see in the electrochemical series. Oxygen getting reduced to, in the presence of acid, to form H2O, and the E0 value is 1.23. These two are different. This is reduction and this is oxidation. This is also reduction, but reduction of oxygen. This is reduction of H2O and this is reduction of oxygen in electrochemical series, not here but in electrochemical series table. So in the from the electrochemical series table, you will see the E0 value of all the reactions that we have mentioned, or that is taking place in the brine solution. So first let us look into the reduction part. In the reduction part, two species, Na plus and H2O, is competing for reduction. Na plus and H2O is competing for reduction. Which one will succeed? Which one will win the race to get reduced? One with higher reduction potential, isn't it? One half cell or half reaction with higher reduction potential will win the race of reduction. Which one is having high reduction potential among this? It is She, standard hydrogen electrode. That means at cathode you will get hydrogen gas, not sodium. So one with higher reduction potential will undergo reduction. I hope it is clear now. Now coming to the oxidation. Here the phenomenon is oxidation, but the values given here is reduction potential. So what will be the oxidation potential? Exactly the opposite order. Again, here the process on the anode is oxidation, but the values given here is reduction potential. So what will be the order of oxidation potential? Exactly the opposite. So if chlorine is having higher reduction, from the value it is clear that Cl minus is having higher reduction potential. That means which is having higher oxidation potential will be this one, that is water. So water is having higher oxidation potential because it's exactly opposite of the values of reduction potential. From the ECS you can see that chloride or chlorine is having higher reduction potential. That means that it is having lower oxidation potential, and water is having lower reduction potential. That means water is having higher oxidation potential. So when it comes to reduction, one with higher reduction potential, E0 value, will reduce, whereas when it comes to oxidation, one with lower E0 value will oxidize. One with lower E0 value will oxidize. So for reduction, water will give H2O, whereas for oxidation, O2 will be given at the anode. So which one is there? O2 will be coming out at the anode. Wait a minute, there is a problem here. Though the electrochemical series is showing a value, showing a potential, sometimes this value is not true, especially if the reaction kinetics or the speed of the reaction is very slow. So this reaction, though the value shown here is 1.23 volt, in real life this is not the true value. Though this is a true value, but this value does not really correspond to the speed of the reaction. Again, sometimes values given here are not true values, because in certain cases this reaction given here, or certain cases the reactions given might be kinetically very slow. Kinetically very slow means the speed of the reaction will be very slow. So for that reaction to happen in much faster speed, we have to give additional potential. This is a potential that I have to supply to this reaction. For this reaction to happen, this is the potential I have to supply. This is according to the electrochemical series. But sometimes this reaction is very slow. That means this potential is not enough. I have to give extra potential for this. That's written here. However, oxidation of water to give O2 is kinetically slow and requires potential higher than that of chlorine. So I have to supply a potential. When I supply that potential, the original potential will go up, and which will be above 1.36 volt. Now which one is having higher potential? Now water will be having higher potential and chloride will be having lower potential, E0 value. So in the electrochemical series, if you look into the electrochemical series, you will see that chlorine is having higher E0 value than oxygen, because in E0 it is reduction, here it is giving oxidation, but it is actually reduction in ECS table in electrochemical series. So in ECS table you will see that oxygen is having 1.23 volt, whereas chlorine is having 1.36 volt. But in real life, reduction of oxygen or oxidation of water to oxygen is kinetically very slow. Kinetically very slow. Why? Because In ECS table it is given the reduction, but here what is happening, it is oxidation. So that is kinetically very slow. So to that event to happen, I have to supply some potential, additional potential. To make it clear again, let's consider again. So from ECS table what you will see is reduction potential. Reduction of what? Here in this case it's reduction of chlorine, and in this case it's oxidation of or reduction of oxygen molecule. So chlorine and oxygen molecule. But what's happening here in this reaction? It is oxidation of water and oxidation of Cl minus. So though it appears to exactly opposite thing, sometimes it is not like that. For example, in the case of chloride, means chlorine to chloride, it is 1.36 volt, and the opposite, it will be exact, the value will be the exact opposite value. But whereas in the case of oxygen to water, the value is 1.23, but from water to oxygen it is not the same. It need an extra potential. So oxidation requires some extra potential, that when you add that extra potential into this value will be above 1.36 of chlorine. So it is called, this extra potential is called over potential. So what is the actual potential of this reaction, this oxidation? It is E0 plus over potential. E0 plus over potential. Okay, then that means that this will not happen. Now electrode will prefer this reaction because potentially, according to the reduction potential is higher than this one, so that means this will happen at the anode and the chlorine gas will be evolved. So again, in the case of multiple electrolyte, there will be a competition for reduction between various species. Here in this case it is Na plus and H2O. Similarly for oxidation there is a competition, and in the case of reduction that competition is won by the half cell or half reaction that is having higher E0 value. So she is having higher E0 value. Why higher E0 value? Because this value is reduction potential value, and one with higher reduction potential value will succeed in reduction. Whereas in the case of oxidation, again if you are looking to the E0 value, this is exactly opposite to the oxidation. So which is having lower reduction potential will succeed in oxidation. But sometimes, since the value and the process is opposite, value is of reduction potential and the process is oxidation, sometimes you have to supply additional voltage because the process will be kinetically slow. So here I have to supply, apart from 1.23 volt, I have to supply an additional voltage. When I supply that additional voltage, which is called as over potential, the entire voltage will be above that of Cl minus. Again, I have to supply additional voltage in this case. So what is the total voltage I should supply? 1.23 volt I have to supply, and in addition to that I have to supply some other voltage or potential. It is called over potential. If you add both these values, over potential and 1.23 volt, it will be above 1.36 volt. Then the lower one will be now that of this reaction, that is Cl minus to Cl2. In that case, at anode, chlorine gas will be liberated. So at cathode, which reaction will take place? One with lower E0 value, that is of She. H2O plus electron giving half H2 plus OH minus. In the solution there will be OH minus, and at the cathode H2 gas is liberated, and at the anode Cl minus is preferred and chlorine gas will be liberated. And what is the overall reaction? Overall reaction can be shown like this. I will explain. Sodium chloride is taken in water as solvent, and from the cathode we have H2 gas because of the reduction of H2O, H2 gas, and in the solution we have OH minus. And from the anode we have Cl2 gas coming out, whereas Na plus from NaCl stays. So I can say that the products of electrolysis are H2 gas at the cathode, Cl2 gas at the anode, and the solution is NaOH. That means with a single electrolysis of brine I will get 3 byproducts. H2 gas at the cathode is a byproduct, Cl2 gas is a byproduct, and the electrolyte, remaining electrolyte, will be concentrated solution of NaOH. So it is multiple electrolyte giving multiple products. This is one of the major advantage of this type of electrolysis, multiple products. Now so to sum up what we have seen in this multiple electrolyte story. So in the first case we saw molten electrolyte is electrolyzed, so there was no problem cations getting reduced and anions getting oxidized. When it comes to the multiple electrolyte, products can be predicted using electrochemical series. How can you predict it? Oxidizing agent, that means the species that can be reduced with high E0 value in the ECS gets reduced. So oxidizing agent with high E0 value in electrochemical series get reduced. So this is the reaction taking place at cathode. At cathode, species with high E0 value will get reduced, and reducing agent that is taking place at the anode, reducing agent get oxidized with lower E0 value in the ECS gets oxidized. Whereas in some cases ECS value is not sufficient for the electrode reaction, as the process might be kinetically slow. This require extra potential known as over potential. This requires extra potential known as over potential. Then you have to add that over potential with the value in electrochemical series. This is especially for the process of oxidation, because oxidation electrochemical series is not a representation of oxidation but reduction. So when it comes to oxidation, sometimes the species might need an over potential, and this over potential plus E0 value, the sum of that over potential E0 value will be the real potential. Now next factor that is affecting the products of electrolysis is the concentration of electrolyte. So still we are dealing with the nature of electrolyte. So the next factor is concentration of electrolyte. Though there are various examples, we will look into the example that is given in the NCERT syllabus, that is H2SO4. So sulfuric acid can dissociate into H plus ions and sulfate ions, H plus and sulfate ions. And since we are conducting the electrolysis of aqueous H2SO4, the electrolyte solution also contains the solvent H2O. So it is an example for multiple electrolyte, and at the same time we can treat this as an example to find the effect of concentration on the products of electrolysis. So if we have multiple electrolyte, what is the case then? Here H plus is there, which is a cation, will try to reduce. At the same time H2O is there, it will also try to reduce. Which part of H2 will try to reduce? H plus. So in acid it is H plus, and in water also it is H plus. So there won't be any competition because they are common. So at cathode there is no competition because both are trying to reduce with the same species. From H2SO4 it is H plus, and from water also it is the positive polar side, that is H plus. Whereas in the case of anode, story is different, because from sulfuric acid it is sulfate, and from H2O, it is O that is trying to oxidize at the anode. Let us see them. So at cathode there is no competition because both the electrolyte, sulfuric acid and water, are giving the same ion, so there is no competition there. We have only one type of ion for that it is a She electrode, then it is 0 volt. There is no competition. On the other hand, anode, we have two types of electrolytes. One is sulfate, the other one is water itself, what try to oxidize to oxygen gas. So we have seen already in our last example of brine solution. Oxygen will get oxidized to O2 because it is in -2. This will come to 0. By doing that, there are two molecules here of water. You can also write like this, or you can write without 2. So you have to make the reaction balanced like what we do in the last part. So 2H2O plus O2 giving, then everything is multiplied, 4 electron plus 4H plus. So if you look into the E0 value from the ECS table from electrochemical series, you will see that reduction of O2, this is what ECS stand for, reduction of O2, and this is peroxysulfate anion. In both cases it is shown that oxygen is 1.23 and the peroxysulfate it is 1.96 volt. So as I said, in this case we have an over potential. So when I added that over potential into this value, it was still below 1.96 volt. So let's assume that when I added the over potential, it is 1.55 volt. I added over potential also into this, and it was the resultant value is 1.55 volt, and the value of sulfate is 1.96. So which one will be the higher one? Peroxysulfate anion will be the higher one, and oxygen is the lower one. So at anode, which one will be preferred? The lower one will be preferred. So in that case oxygen will be evolved. So if you are taking dilute H2SO4, you will have hydrogen at the cathode and oxygen at the anode. Hydrogen at the cathode and oxygen at the anode. So oxygen is evolved if it is dilute H2SO4. What I am looking is effect of concentration. That means instead of dilute sulfuric acid, I am going to take concentrated sulfuric acid. So first, with dilute sulfuric acid, what happened? Oxygen is evolved at anode for dilute H2SO4 because its potential, what is its potential? Its E0 value plus over potential is lower than that of sulfate ion. So this value plus over potential is lower than that of this value. In previous case of brine, value of chloride was 1.36. When I added this E0 value with over potential, it was above that because it was approximately between 1.5 and 1.6, the total value between 1.5 and 1.6. So that means it is above 1. But here it is 1.96 in the case of sulfate. So the total potential, that is E0 value plus over potential, is still lower than that of sulfate. So in that case oxygen gas is evolved because it is having lower potential. What about if I am adding concentrated sulfuric acid? Instead of I am taking concentrated sulfuric acid instead of dilute H2SO4. That means with concentrated sulfuric acid, the amount of sulfate increases. It far exceeds the value of, or far exceeds, dominate. In that case, we don't have to look into the E0 value. So with higher concentration of sulfate ions, then it is preferred over the other one. So in the case of concentrated sulfuric acid, peroxysulfate anion is accumulated at anode for concentrated sulfuric acid due to the high concentration of sulfate in the solution. Due to high concentration of sulfate, this one will be preferred. So this is the effect of concentration. Clear? In the case of dilute sulfuric acid, E0 value plus over potential is still below the sulfate, so this is preferred. Whereas in the case of constant sulfuric acid, due to very high concentration of sulfate, it is this reaction of sulfate, oxidation of sulfate to peroxide sulfate. Sulfate is in +6 oxidation state here, and peroxide sulfate sulfur is in +7 oxidation state. So this is preferred. Details of this structure we will see in P block elements. When you learn the oxygen family, you will see the details about the structure of this compound. Then it will be easy to remember. For the moment, you have to study this reaction, sulfate 2 minus to S2O8. You just add it 2 times, S2O8, still keeping the oxidation number. The difference is that here sulfur is in +6 and here sulfur is in +7. So the difference between the two is just 1 electron. Here there are 2 molecules, so it will be 2 electrons. Okay. So far we have discussed about the nature of electrolyte. In the first case we discussed about the molten electrolyte. In the second case we discussed about multiple electrolyte. This is also an example of multiple electrolyte. And finally we also looked into the factor, that is concentration of electrolyte. All these we have seen that can alter the products of electrolysis. Next we are going to concentrate on the type of electrode, type of electrode. So far we have seen nature of electrolyte. Next we are going to see type of electrode. So what type of electrodes have we have studied until now? There are 2 types. One is inert electrode and the other one is reactive electrode. So electrolysis of same substance give different products with active and inert electrodes. So if you are taking same electrolyte and if you are using active electrode, then the product will be different if you are using inert electrode instead of active one. So reactive and inert electrodes. First let's see an example for reactive electrode. Reactive electrode. We have already seen this in the purification of copper. So in the electrolytic chamber we have both copper strips. One is impure copper, which is connected to the positive terminal of the battery, and the other one is pure copper, that is connected to the negative terminal. And in the solution we have Cu2 plus ions. That means copper is a reactive electrode. And what happens from the positive side, we have impure copper. Generally this copper is blister copper. The details about this production of blister copper or impure copper, we will see this in the chapter of metallurgy or the purification of elements. So for the moment we have to see that this is a copper that is extracted from its ore, and we get somewhat pure but not perfectly pure. We call it as impure copper or blister copper. And whereas on this side we have a narrow strip of pure copper that is connected to the negative terminal of the battery. So from the impure copper, once when this cell is on, from the impure copper Cu2 plus slowly dissolves into the solution. So by doing that, impure copper, thickness of the impure copper reduces. It will become more and more slimmer because Cu2 plus is going to the solution. The Cu2 plus, since it is positively charged, will move towards negatively charged electrodes. So in between there are a lot of events happening, but for the time being, or for in the +2 syllabus, you don't have to go into that details. So we will just make it like this. From impure copper, Cu2 plus will go into this solution, which will move towards negatively charged electrode and will get deposited as there. So what happens? Thickness of this copper strip increases. Only Cu2 plus ions will move. There are a lot of different chemistries involved here, but for the time being you have to learn only this. Cu2 plus will get deposited here. Thickness of this strip increases, and the pure copper, after it is too thick, it is taken off, and a pure strip is placed. This also is removed and pure one is removed. So what happened to the impurities? Impurities will get deposited here because it will not move through the solution, and this we call it as anode mud, because it is the impurities from the anode that is getting settled down as a heap under the anode. So it is called anode mud. What happens in the anode? In the anode, Cu, that is in impure form, goes into the solution and leaves 2 electrons on the electrode. So it is oxidation, and hence it is anode. Whereas in the cathode, the Cu2 plus moves in through the solution and reaches the cathode and get deposited there as pure form. So this is the reaction, and this reaction has a big significance in the electrochemical process. That is, this method is used for refining and purification or purification of copper. Both the terms implies the same thing, that is refining or purification. So electrolysis is the method that is used for the purification or refining of copper. Why do we need to do this, use this? Because okay, that we will discuss later. This method is used for refining or purification of copper. Now what happens if I am using inert electrode instead of reactive electrode? Which is the best example for inert electrode? That is platinum electrode. So what happens if I am using an inert electrode instead of reactive electrode? Let's see. So if I am using an inert electrode, so I am using, instead of a reactive electrode, I am using platinum here. So I have replaced copper strips with platinum. What happens? Let's see. Let's imagine that the counter ion of copper is Cl minus, and it has also water inside it. So let's imagine that it is Cu2 plus and Cl minus. Cl minus. What happens? Cu2 plus will move towards the cathode. Along with this, we have also water molecule moving towards the cathode. Then Cl minus will move towards anode. Along with this, again we have H2O moving. So there is a competition at the anode. Which will win? We have already seen in the case of brine solution, it is Cl minus that will win. Actually it is oxygen, water that is supposed to be get oxidized, but due to its over potential it cannot get oxidized, and Cl minus will get reduced to Cl2, get oxidized to Cl2. Whereas in the case of cathode, again water molecule and Cu2 plus will compete, but water molecule, as we know that it is standard hydrogen electrode, its voltage is 0, whereas in the case of copper it is 0.34 volt. So it's having higher reduction potential, and hence it will get reduced at the cathode, that is Cu2 plus. So in the electrolytic tank we have taken CuCl2 solution, aqueous medium. What you have to mention, aqueous medium, and it dissociates into Cu2 plus ions and Cl minus ions. Cu2 plus and water will move towards cathode, Cl minus and water move towards platinum, towards anode, and Cl minus will get deposited there, and Cu2 plus get deposited at the cathode. H2O will also compete, but its E0 value is lower than Cu2 plus for reduction, and its potential, that is E0 plus over potential, is higher than Cl minus for oxidation. So you have to also mention that. So what happened? What is the difference when I used inert electrode instead of copper or reactive electrode? When I used a reactive electrode, I was able to purify copper, because copper is going to the solution at the anode, and at the cathode copper is getting deposited. Whereas when I used platinum electrode, anion started moving towards the platinum and is getting deposited there. So there is a big difference in the products of electrolysis. In the last part we saw how current, electricity, and what is the amount of substance that is deposited, all these things. In this we were dealing with the different factors that changes the products. You might expect something, but you are getting different thing. That is controlled by a lot of different factors. Those factors were what we were seeing in this part. Last one, what is the effect. What is the effect of silver and platinum electrodes in the electrolysis of aqueous silver chloride? What is the effect of silver and platinum electrodes in the electrolysis of aqueous silver chloride or AgCl? First we will see the effect of, so it is not AgCl, it is AgNO3. What is the effect of silver and platinum electrodes in the electrolysis of aqueous AgNO3 solution? So first we will see the products of AgNO3 if we are using silver electrodes. Products of electrolysis of AgNO3 solution with silver electrodes. Ag is a reactive electrode, so electrolyte contains Ag plus ions. So since as we saw in the case of copper, we are using Ag electrode as cathode and anode. So at the anode it will be impure form and the cathode it will be pure form. What happens at anode? Ag, which is solid, will go into the solution as Ag plus. What is the charge of anode? Anode is positively charged. So from positively charged it will release Ag plus into the solution. So Ag goes into the solution, whereas at the cathode Ag plus accepts electron and get deposited as Ag metal. So Ag gets deposited at the cathode. So this is what this was what happened for the copper also. So a similar case, similar thing will happen in the case of silver nitrate if we are using silver electrodes. Now what happens in the case of products of electrolysis of AgNO3 solution with platinum electrode, with an inert electrode? Now solution has Ag plus, NO3 and multiple electrolytes. So Ag plus and H2O will compete for the cathode, and NO3 minus and H2O again will compete for the oxidation, but NO3 won't compete. We will see the details about this. So first, for reduction there will be competition between Ag plus and water, and who will win? One with higher E0 value will win. So Ag will get deposited at the cathode, whereas in the case of oxidation only H2O will compete. Why? Because in the case of reduction Ag plus has high E0 value, so reduced. In the case of nitrate, it cannot be oxidized as it is in its maximum. Nitrate is in its +5 oxidation state. In the case it belongs to the group 15, and in group 15 maximum oxidation state is +5, which cannot be oxidized further. So it is not able to oxidize NO further, N further, nitrogen further. So because of that, nitrate will not compete for oxidation. So who is remaining? Water is remaining. At anode, oxygen gas will be evolved. So what are the products? The products will be silver at the cathode, oxygen at the anode, and the solution will be of HNO3, that is acid. Again we have three different products: silver, oxygen that can be used or taken in the chambers, and also nitric acid as the products.